Okay, before we get started on the word class, I want to do some cleanup on the game class. There's some light refactoring we can do to make things better. I don't want the individual modules to all be doing print statements. This might be overkill, but I think this is a much better way to write it. I want all my input and output going through this screen class. Why have it if we're not going to use it for that purpose? So I came about this decision when I was writing unit tests, and we'll get into that in the next video. Just know that you should never have to modify your code in order to write unit tests. But through the course of writing the unit tests, you may realize that you could have written something better, more efficiently. And that's okay. Don't be afraid to refactor your code if you think of a better way to do something. And I believe that I have. I don't like this word.show method. I don't like relying on this word class to print to the screen. I don't like, the other print statements. So we're going to put those in the screen. We're going to come over to the screen class, and we're going to create a get method and a put method. Static method. And as a refresher, these are static methods because there's no reference to an instance variable. There's no self in here. All of the methods for the screen class are going to end up being static methods. So it's effectively a static class. You would never instantiate a screen object. You would just do what we do here and just reference the class and then the methods in the class. One of the nice things about doing this, by putting this new line in here, and the only reason the new line's in there is just to make things look prettier in the console window. We can then now control those things here in this class rather than requiring the person calling it do that. We're also going to create a put method. The other valid reason for putting these things into the screen class is, you think about it, the game class should be agnostic to how the user is actually being interfaced with. In theory, you could have a GUI front end on this, and the user could be clicking things with their mouse or whatever. The game class shouldn't be thinking about that. The game class should only care about in and out. And so you may change the way it interfaces with the user through some other intermediate class. Maybe instead of a screen class, you had a interface class or whatever. It doesn't make sense to have the game class printing or receiving. It should work through some intermediary that could then change in the future. And while we're in here, let's go ahead and put in a goodbye method. I'll just go ahead and copy this. And over here, we need to replace the goodbye. And the prints. I'm going to cast this error, the string, this except guess error. Remember, we created our own guess error class, which inherits from the base exception. So if you were to just print this, it would convert it to a string. But because we're going to pass it to a different method, I'm going to go ahead and do the conversion right here. I think this is superior code personally. One last thing, this word.show, I now need to tell it exactly what to do. Which means there's one less method I have to worry about. I was never really happy with that show method. One of those things that, you know, when you're writing code, you may write something, and even as you're writing it, you might feel like, you know, this feels wrong. Something about this isn't sitting well with me. You should listen to that feeling. Okay, let's go ahead and run Pylint. Make sure our Python path has our directory here. Okay, we haven't updated the fake word class yet, so let's go ahead and do that while we're in there. While we're doing all this. We'll write the real one shortly. Apparently we need a masked method. Property, excuse me. And we're not going to need this show method anymore. And while I'm in here, let me go ahead and put my Skittles in the correct order. Well, of course I don't have doc strings. I'll Pylint word when we've actually written it. Those new lines are easy to get. I actually see a trailing line by itself. Okay, now we're ready to move on to the word class. One of the nice things about doing this the way we've done it is we already know the methods that we need to do. Maybe we should put in our doc strings. Remember that this is a private variable. Keep track of all the guesses in one list. And we're going to compile an input pattern so that we can use it to compare the user input to make sure that it's valid. Now our regular expression is going to be beginning of the input. We want a capital letter A to Z. And we want a single character and then the end. So we'll have to convert. We could do this, but we're going to convert the input to uppercase automatically anyway. So our valid pattern will just be a capital A to capital Z. Now we're going to have to import that if we want to use that module, regular expression. How will we know if the game is alive? Well, we'll know the game's alive if the number of incorrects is less than 6. So how do we know the number of incorrects? Or how do we know the incorrects? So I'm going to walk you through the traditional way of doing it, and then I'm going to show you the list comprehension that I would use. So you want to create a list. And you're going to iterate through all the guesses. And you're going to check to see if that guess is in the word. This is probably how you've been writing code your whole life. And it's perfectly fine code. But in Python, we want to use list comprehension. So we're going to return x for x in self guesses if x not in self word. We're saying iterate for x in self guesses. So iterate through all the guesses and assign each item in that list the variable x. And if that item is not in self word, then include it. So this will turn a list of the incorrect guesses. This is cleaner code and it's faster than iterating through it manually. All right, now we're going to do a mask. This is going to be your word where it's underscores if they haven't guessed it yet, or the revealed letters if they have. And we're going to do this, another example of when list comprehensions are awesome. Let's write it the traditional way. So if they've guessed it, then go ahead and reveal it. Otherwise, stick an underscore in there. And then join them all together with a space. Perfectly reasonable code. But if we're going to do a list comprehension, so we want to have an X. We're going to go for X in self word, right? So iterate through all the letters and give me that letter if it's in the guesses, right? So just give me the plain letter. Otherwise, give me an underscore. This is equivalent code, all written in one line, and it's faster. Solved. How do we know if it's solved? Well, this seems like an easy way to do it. Just check to see if there's any underscore in the masked property, because if there isn't, it's solved. This is a good example of not duplicating code. Don't repeat yourself. We've already written code that goes through and determines how many of the letters have been guessed. There's no reason to do it again. Just rely on that same code here. Unmasked is just the initial word. And then finally, we've got a method here, guess. So first thing we're going to do is convert that to an uppercase. Now briefly, I want to touch on this because it's so important. And if you haven't watched the video on mutability and you don't have a good grasp on that, you should probably watch that video. But the reason it's okay to do this, normally you get to be very careful when you've got methods or functions when you're modifying the initial argument. Because if this is mutable, then the change you make is permanent. Right? So if this were a list of some kind, and I come in here and pop it, then this list is popped because this is a mutable object. Strings are immutable. Can't change a string. A is always A. If you try to manipulate it, it becomes a whole different string. So that's why I can convert this to an uppercase and it's not going to do anything to the argument. So I'm going to first make sure that it's valid input. The reason I put this compilation up here in the constructor, so I only have to do it once. I don't want to have to do the compile every time I guess a letter. This is one of the nice things about classes. Because it's a class, I can have instance variables. That's what this is. When I instantiate a word object, it has its own pattern that goes with it wherever it goes. So this is a very flexible thing about classes, is I don't have to recompile something over and over and over again. We're going to make sure that it's valid. Otherwise, I'm going to raise a guess error. We need to import guess error. Something else we need to check for is make sure they haven't already guessed the letter. Now, if they haven't, it's a new guess. Just add it to the list of guesses. Otherwise, we gotta tell them, hey, you already guessed that. And that's our word class. Pilot against it. Oh. I'm going to go ahead and run. I've already got my path set up over here. Trailing white space, very common. I'm hesitant to do. Oh, I'm sorry. There was one more thing I wanted to change. I apologize. I should have done this earlier in the video. Back in that game class, I want to modify this import. I want to change this import to match the other ones. And that will also require me to go into the init.py at the root level and remove this. The only thing that really should be in here are things that you're going to want to be able to import at the global level anyway, which is just going to be game. I mean, no one should be importing things from our Hangman module. Why would you ever need just the dictionary class, for example? You could probably make a good argument for the guess error to be in here. Well, let's not overly complicate things. That's good. Change game again. Let's make sure that's still good. In case you haven't picked up on it, I really like Pylint. I find it very valuable. Now, I need to say it, but I think our game should be runnable at this point. So, should we run it? Let's see what happens. Well, look, there's Gallows and a word. I like to start with the vowels. Gotta be vowels in there, right? Huh. Oh, I must have made a mistake somewhere. Right here, lowercase. At some point I forgot to do the word upper. Probably should be in the dictionary class. Now here's a philosophical question. Where should we convert it to uppercase? Should we do it in the dictionary class? Or should we do it in wherever we're doing the get? I would argue we should do it wherever we're doing the get. In the game class. Because maybe not everyone who would use the dictionary class is going to want that changed to uppercase. We know for our game, we want to do that. The other place you could do it is in the word class. Maybe the word class. Actually, now that I think about it, that makes sense. There we go. I'm sorry. That makes more sense because the game class, and I apologize for all this, I'm doing this on the fly here. The game class really should not have insight as to how the word class works. The game class just needs the interface. Hey, I want you to get a word. I want you to, right, I'm going to pass you guesses and then you tell me how I'm doing. I don't care that in the back end, the word class is going to worry about the capitalization of that. So it makes sense to put it in the word right here. This is where it should be. And if you don't agree, fight me. All right, still good. Main. Why? That's a shorter word. Hey, there's vowels this time. Twangy. Should have guessed. Hey, we have a working Hangman game. But we're not done. There's still unit tests to write, and that's very important. We've got plenty of technical debt left behind, and we wouldn't be good software engineers if we just left it like that. So next video, we're going to clean that up and write unit tests, and that will prove valuable because after that, we're going to add some features. We're going to add some more functionality. And the nice thing about having those unit tests is when we write new code, we'll be able to test to see if we broke anything that already existed.